The first section that we're going to have on our quiz tomorrow is from section 4.1. Remember, that's where we did distance, midpoint, and slope. All right, and so we've got our distance formula. Fine, made a pit. All right, so I will give you these formulas on the quiz tomorrow, but I'm not gonna like label which one's which. Like, you need to know, like, be able to recognize that this is the distance formula, and then that like midpoint is the one with the capital M that looks like this.
When is this quiz?
Tomorrow. Yep, so like it'll basically be like this, just on your quiz paper. You just need to be able to recognize which one is which. And for all of these questions, right, you're going to be given two sets of points, or a set of 2 points, I should say. So like one, right, and so when you have this, remember that you have x1 and y1, x2 and y2. And so you just plug those numbers into your formula, and then that'll give you your answer. Okay, so then from section 4.2, that was the one that we did a lot of graphing with. I'm not overly, I'm worried about the graphing, but it's going to be more graphing from slope-intercept form. Right, so remember that form is y equals mx plus b, right? So that's an equation that's solved for y, where m is the slope and b is your y-intercept. All right, so remember the y-intercept is going to be where it crosses the y-axis. So you need for these, you need to be able to look at an equation like this and put it on a graph. So let's just do an example of that really quickly. So let's say it's 2/3 x plus 3. So that means on my graph, all right, so that means I'm going to go up to 3 on the y-axis and put a dot there to start, because that's my y-intercept. Right, and then that slope is positive 2/3. So that means from my green dot, I'm going to go up 2 and right 3. So I'm going to go up 1, 2, then 1, 2, 3, and put a dot. Right, and then you can do it again from that blue dot to just extend your line out a little bit further. So 1, 2, 1, 2, 3. And then you just connect those, and that gives you your line. All right, so that's really the only well, and then with intercepts is going to be the other method of graphs that I want you guys to be more familiar with, which we'll go over here in just a second. And while we're talking about slope-intercept form, I want to do a couple examples of converting equations, or putting them in slope-intercept form. Right, so that's one. So let's say we have 10x plus 5y. So remember, when we're putting it in slope-intercept form, all we're doing is solving for y. So we're going to subtract our 10x over. So then we get 5y equals negative 10x minus 45. Then we would divide everything by 5. So that means our equation would be y equals negative 2x minus 9. And that's our equation in slope-intercept form. So then, like on the quiz tomorrow, I'll have you do this, and then you're going to graph the equation that you get. Right, so we would then graph this equation, like we just did on the example before.
You put negative 2 over 1. Right?
Yeah, so that's how you would use that slope. So then that means you would go down 2 and write 1. Sorry, I was looking for a good example equation. All right, so x. So we're going to add 6 over. So when we get 6 equals 3x divided by 3. So that means our x-intercept is 2. Right, and then what do we do to find our y-intercept? Yep, so to find the y-intercept, we're going to plug in 0 for x. So that means we have y equals 3 times 0 minus 6. So the 3 times 0 cancels out, so we just get y equals negative 6 is our y-intercept. So then to graph these, for the x equals 2, we just go over 2 and put a dot. And then for the negative 6, 1, 2, 3, 4, 5, 6. Don't make your graphs as tiny as I just did right there. I'll have graphs on the page for you tomorrow. That way you don't have to worry about having to draw it. You just have to plot the points, which will hopefully save time. All right, and so it looks like that. Okay, and then the other thing from 4.2 that we need to go over is using point slope form. So that's where you write the equation of the line and put it in slope intercept form. Right, so for that we have all right, and for questions like this, again, I will give you that formula. You don't have to memorize it. So you will be given a point and a slope. And so you're going to plug those numbers into your formula and then solve it for y. Right, so remember this is x1. My pen's about to die. So then we have y minus y1, which is 2, equals m, which is negative 4, times x minus x1. Right, so we are subtracting the negative 13, right? I think this is where a lot of people made mistakes on this assignment. You've got to pay attention to those signs. Right, when you're subtracting a negative, that's going to become like a positive 13. All right, and it's okay if you want to go ahead and jump to this positive 13 as you plug it in. If that's going to be easier for you to remember, I'm fine with that. All right, so then we distribute the 4. So we have y minus 2 equals negative 4x plus 50. That's right. Yeah, 52. So it's going to be a minus 52 actually. And then we add 2. So that means our equation will be y equals negative 4x minus 50. All right, any questions with point slope form? Okay. Last section that's going to be on our quiz is 4.4. So that is with functions. Right, so that one's going to be just like that assignment we did on Monday, where you have to determine if something's a function from the list of ordered pairs or looking at a graph, and then evaluating the functions, which is the worksheet we did yesterday. So remember from ordered pairs. So let's say we have 1, 0, 2, 1, 2, negative 1, 5, 2, and 5, negative 2. So is this a function? No. Why not? Right, so we've got 2 2s here, and we have 2 5s here. So this is definitely not going to be a function. Right, you can't have any repeating x's. All right, so then let's do one more. All right, what about this one? Yes. Right, so again, we don't have any x's that repeat. So that makes this a function. All right, and if we have a graph, how do we test if it is a function? All right, what kind of lines? Nope. Vertical lines, right? It's called the vertical line test. So for this graph, is this a function? Yes. What about this graph? No, right? Because look, it's going to touch it 2 places. Okay, and then let's just do one quick example with evaluating functions. So for that, you're going to be given some kind of function. And then it's going to tell you to evaluate it when x is equal to something. So let's say 2. Keep it easy. Right, so that just means you're plugging in a 2. So you're going to do 4 times 2 minus 12. So 8 minus 12, which is negative 4. Plugging in numbers.